Hey everyone, welcome back to my YouTube channel. And today we are again going to solve this Leetcode daily challenge, which is minimum number of vertices to reach all the nodes. So let us try to read this question. Given a directed acyclic graph with n vertices numbered from 0 to n minus 1 and an array edges where the array edges are equals from I into I represent the directed edge from node from 1 to node to 1. Okay. Find the smallest set of vertices from which all nodes in the graph are reachable. It is guaranteed that a unique solution exists. Okay. So it is saying that I need to find the smallest set of x such that I will be able to reach all other nodes. So let's say if I pick one, can I reach all other nodes from one? No, right? Because from one I can only reach one. Let's say if I pick four, can I reach all other nodes? If I pick four, let's say if I pick four and three. So with 3 I can reach 3, 4, 2, 5, and with 4 I can reach 4 to 5. I can't reach 0 and 1 in any under any condition, right? So 3 and 4 are not valid sets. If I take 0, 1, 3, 4, is it a valid set? Can I reach all of them? 3, 4, 2. If I take 3 and 4, I can reach 3, 4, 2, 5, and if I take 0 and 1, I can take 0 to 5. See, I can reach all the numbers, but then this set won't be minimal because I can actually use 0 and 3, and I can still reach all of them, right? See, if I take 0, I'll reach 1 to 5. If I take 3, I'll be able to reach 3, 4 to 5, which is covering all the nodes in the graph. So what is the minimum number of nodes that we require? So minimum set of test nodes. So you can see that this is you can take this as a hint. It's a directed acyclic graph. So think about it. Pause the video and try to think of a solution, and if you are able to come up with a solution, comment in the video itself. So one thing you have to notice is that if a graph has an uh, like what are the nodes that we have to pick up, like it's an like no matter what happens we have to pick up those nodes. So you see we uh, have to pick up 0 and 3, right? Because there's no way to reach 0 and 3. We can't reach 0 and 3 from any other node, right? So we have to pick up 0 and 3. So once we pick up 0 and 3, do you think that we need any other node? Don't just like prove it by example, prove by intuition, or like give proof by contradiction or anything, because proving by example is it can fail at other examples, right? Here in this example you can see that it is passing that if we just pick 0 and 3, the nodes which have 0 in degree, we are able to reach all other nodes. But is it a sufficient condition that we just pick 0 and 3? So what can happen is that, so let's say if I pick a node with in degree of 1, do I need to pick it or not pick it? So if there is a node with an in degree of 1, let's say node 1 has an in degree of 1, it means that it has at least one edge, right? Which means it is there is at least one node which is uh, from which it can be reached, right? So we don't so let's not pick this node. If I, let's say, okay, let's try to revisit what I'm saying. So let's say if there is a node with in degree of 1, it might be possible that there would be a node 2, and it will be connected to node 1 somehow, right? And just the degree of this node 2 will be, let's say again, it's 1. So again you can see that this node 2, this will also be reachable by some other node. Let's say node 3, node 3. Let's say this also has this has a degree of 2. So this node 3 will be reachable by two nodes. Let's say we pick only one of them, and let's say node 4. So at the end, you know that there would at least be one node with in degree of 0, which will from which this will all start, right? So if we pick only one single, if we pick a node with in degree of 0, then we are sure that these nodes will be picked up, right? This can be visited. So there is no need to pick up nodes which have in degree of 1 or 2. Similarly, we can prove it. So yeah, let's try to code this up. Oh, okay, I don't think we have to do all this. We just need to calculate the in degree. System edges of size I plus. I don't know what's happening. So it's from to 2, right? The first is from and second is 2. So we will say that in degree of edges I 1 plus plus. And let's create an answer vector. Indeg if x equals 0, answer dot push back x, and then we return x. And let's try to simplify the code here too. And yeah, I think it should be fine. Edges, okay. Okay, what is this? Number 18. Answer. A follow-up question. Okay, so it's giving no. Okay, x equals. Oh, actually, I have to do the indexing here. Otherwise, I'll just keep pushing 0. Yeah, so a follow-up question can be first let's try to submit this, that okay, it got accepted. So yeah, so a follow-up question can be that what if this is not a directly acyclic graph, it's an undirected graph, right? So in that case you would think about it, what would the answer be? So pause the video and think about it. So I hope you guys would have given it some thought. So in case it's an undirected graph and all the nodes are connected, let's say here in this case itself, so the answer would be 1. But if there are more connected components, we can say that the answer would be the number of connected components. So for each component, we just need to pick one such node, and we can visit all the nodes in that connected component, right? Yeah. So I hope this was helpful, and I'll upload this video, and I hope you guys stay motivated too and do Leetcode daily. Okay, goodbye.